Okay. Problem 9.16 says a 10 ohm resistor and a 5 microfarad capacitor are connected in parallel. This parallel connection or combination is also in parallel with the series combination of a 8 ohm resistor and a 300 microhenry inductor. These three parallel branches are driven by a sinusoidal current source whose current is such right here. Right? So it wants us to draw the frequency domain equivalent circuit. So we're going to draw the circuit first, right? So we know that we have a current source. I'm going to call this I, or actually, let's do it. It's a little hard to. This is, I'm going to call this. Yeah, whatever. And we have a resistor and a capacitor in parallel. So I'm going to draw the resistor first. Capacitor, right? And then we have a series combination that's also in parallel with these two. Let me write this. Okay, like that. So 300 microhenry, 8 ohm resistor. So draw the frequency domain equivalent circuit. So 10 doesn't change. I'm going to draw this in red. So you know that our equivalent fit, I guess, phasor or equivalent, yeah, frequency domain or uh, yeah, frequency and impedance, I believe. Anyways, we can call this. We can go ahead and say um, that this capacitor would be negative J over CW, and we just plug this in. So for our capacitor, 5 microfarad capacitor is J over 5 e to negative 6 times 2,000 or 20,000, sorry. I believe that results in negative 10 J. So this would be negative 10 J, right? For our inductor, it would look like this. So we plug in, I guess, inductor 300 microhenry. We would multiply 300 e to negative 6 times 20,000 J, and that would result in 100 to negative 6 times 20,000, 6J, right? Cool. So essentially, if we were to want to find the impedance, we could just sum it up. This is not really what the question is asking, but I'm going to do it anyways. The equivalent for all of them would be 10 parallel with 10 J parallel with 8 plus 6J, right? So yeah, that just becomes something way more complex, and we're really not asked to deal with it. But yeah. So it says reference the voltage across the current source as a rise in the direction of the source current and find the phasor voltage. I guess actually we do need it. So we need to find the Z equivalent. So I'm gonna go ahead and make some more space down here. Oops. Okay, so the Z equivalent would be 1 over 10 plus 1 over negative 10J plus 1 over 8 plus 6J. Yeah. So we can go ahead and say, I'm not really going to do the math here, but the equivalent would be 90 over 17 minus 20 over 17J. I can actually just go ahead and plug this into Symbolab if that makes anything better. Yeah, let's do that. Uh, over 8 plus 6. Instead of calling it J in Symbolab, you call it I. That's what this calculator recognizes. And so, show you here. There might be something I'm doing wrong. Let's give it a look one more time. Might as well put this to the side here. And wait till it loads. After a while loading, we get the answer here. Here might as well just not. Okay, there we go. So we didn't really need to solve this by hand. Anyways, after obtaining this, we get the Z equivalent. We can go ahead and find. Yeah, we can go ahead and find the amplitude and the angle. So amplitude is going to be 90 over 17 squared plus 20 over 17 squared. And that is going to be 5.42 326, 1445, and I'm just going to keep that value because I want my, we can use the decimals, but I'm just going to keep it that way. So that way my answer is exact. And now we want to find the angle. So we want tangent, tangent of negative 20 over 17 over 90 over 17, which is negative 12.5288 degrees. So the equivalent is going to be 5.42 blah, 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 at a negative 12.53 degrees. Okay. So then we can yeah, we can put this in phasor domain. Yeah, and so we can put this in phasor domain or not. At the end of the day, it's up to you. So we're actually, I'm just gonna do this 5.42 blah blah blah. So it wants us to find the voltage. So I guess no need. Voltage would be I times Z. So domain would be cosine 20,000 T minus 12.53. So then our current 922 I believe. Is it 19? Yeah, 922 cosine of 1000 T plus 30 times so 922 times 4 point, or actually 922 times 5.2 1445. Yeah, that'd be closer to the answer. I guess we don't necessarily yeah, let's put this in phasor domain. So and then let's do that. We put our current 922 E2, I think it's 30. Yeah. J. Okay, so 22 to 30 J times 0.4233, or no, 32. Whatever big number we got here, e to the negative 12.53 J. It's going to result in 5,000.247 e to 30 minus 12.53 is going to be 17.47, I think. 0.47, and we can solve 5,000.25 cosine of 20,000 T plus 17.47. And this right here would be our function for our voltage. Yeah. our steady state expression for the voltage across. So yeah, this is it.